So, the past criteria are all described. So that's sort of a brief, brief description. So maybe a sentence or two or three. And that's all the. That's the minimum amount that you need. So, lifestyle choices, how they can affect human health. I'd recommend saying at least two or three positive and two or three negative lifestyle choice, and roughly how they affect your health. Describe how pathogens affect human health. I'd recommend talking about viruses and bacteria. Give two examples of viruses or bacteria. So, for example, AIDS or corona for viruses. Staphylococcus aureus or E. coli for bacteria. That could be two examples. I recommend doing a bit of research into it. It will not be hard to find different examples for this and talk about how it affects the body. Two different treatment regimes, one to prevent and one to treat disease. I'd recommend giving two examples of each. So for prevention, it could be something like healthy lifestyle, and explain how this would prevent a disease, or what disease it would prevent, or such as vaccination, and just a brief description on how that can prevent a disease. Treatment could be something along the lines of physiotherapy. It could be surgery. It could be antibiotics. It could be numerous things. We'll go into that detail a little bit later. Advantages and disadvantages of the vaccination program, that should be self-evident. Explanation of the use of pedigree analysis, I'll go into this in a bit. Explain how bacteria can be resistant to antibiotics. So these three require a little more detail than the describe bit.
Okay.
So this is sort of just stating what it is. This is pros and cons of it and the limitations of the pros and cons. This is stating what the pedigree analysis is and explaining how it can be used for the benefit. That's sort of the merits part. I'm going to mute everyone just for a second.
If it's farting or whatever, that's gross. I mean,
Where's my power? There you go, power play, mute all. Nice try. There you go. Explaining how bacteria can be resistant to antibiotics. So this is more than just stating survival of the fittest. You have to explain sort of roughly what antibiotics do, how some bacteria could survive, why mutations can allow them a slight advantage to it, how these mutations and slowly build up the resistance of the bacteria to the point where they completely chill with you trying to poison them. And then the final part, the distinction, is the evaluation of the use of antibiotics, pedigree analysis, and vaccination in the treatment and prevention of childhood illnesses. I'll explain this at the end of the lesson and it'll become more obvious. Okay, it's going to look a little weird for a second whilst you guys won't see the weirdness, but the video will. There you go. Let's share. Can you see biology and the environment part C?
yes.
Nice.
C.
Wonderful. Okay, let's run you through it. Lifestyle choices and how they can affect human health. So a lot of the detail will be verbal when I'm explaining this. Eating well. If you have sufficient nutrition, you will not suffer from nutritional deficiencies that can cause diseases. Also, proper diet can allow your body to fight diseases that you have, in the sense that it has the fuel to do so. Furthermore, proper bacterial, a really good strong microbiome in your gut can actually fight against diseases themselves. So for example, if you've got a very complex gut biome, it's less susceptible for bacterial infection, so you would get food poisoning less often, as an example. Exercise and stretching, this can prevent physical diseases, or certainly help out with physical diseases. If you've got a disease that degrades your muscles, but you exercise them enough, it will slow down the degradation, so to speak. Sufficient sleep and regular sleep, and this is probably a problem for most of us. If you don't get sufficient sleep, say you sleep 2 hours less than you need to, and now everyone varies, but it's usually around 7 to 9 hours for most people. If you sleep 2 hours less each night, you have a hormonal profile of someone about 10 or 15 years older than you, and that's not a good thing. That's not a good thing. It increases your chances of having Alzheimer's by something like 4 or 5 times. And you don't function well. Here's a really good statistic for you, because has it just happened, or it's just about to happen, and the clock is about to go forward or backwards. That's just happened, right? Yeah, I think that happened on Sunday, and it's the bad one, the one where you get less sleep. So when this happens, there's a 25% increase in heart attacks that are seen in hospitals.
Why?
Numerous reasons, but sleep is very important. I would say something along the lines of stress. I'm not entirely sure why, but it's a significant statistic. And equally and oppositely, at the other time of the year where we get an extra hour of sleep, there's 25% reduction of cases of heart attack for that day.
Just to be sure, there's nothing wrong with oversleeping.
There is something wrong with oversleeping. You don't want to have too much sleep, but it's better to get too much sleep than too little sleep. With sleep, you want to have a regularity with it as well. So you want to wake up at the same time every day. So your biological rhythm, or it's called circadian rhythm, which dictates sort of the starting point of all your biological functions, is regular. I won't go into a tangent for that at this point, because I want to get through this quite quickly. Unnecessary stress, cortisol and stress can make you ill. It compromises your immune system. It causes inflammation, and inflammation is a factor in about 50% of illnesses. Sunlight. Sunlight's very important in terms of getting adequate vitamin D, which is used in over about 2,000 metabolic pathways in the body. It's important for your mental health. It's important for your physical health, and most people in the northern hemisphere don't get enough. Could you mute yourself, please? More mental health, lifestyle choices, meditation, social contact, hobbies. Social contact in the sense that we are social creatures, and I think that the world's going to get a little bit of a wake-up call in the negative effects of having a lack of social contact on a mass scale with this coronavirus. It'll be interesting to see what comes from that. But we are social creatures. If we have no human interaction whatsoever for something like 6 to 8 weeks, we start going mad. Quite legitimately. It's found that that's the sort of where the stereotype of the mad person who lives in the wood comes from, is because complete isolation from any kind of human contact literally leads to some sort of madness. Meditation is a way to control the mind, it's a way to control the body, it's a way to reduce stresses, it's a way of looking at the world through... It's a way of resetting your baseline mentality. That has a profound effect on human health because it can boost your immune system, it can, I've said, reduce stress, which is a big one. And hobbies, this is more of an Andy's interjection with this. Hobbies allow you to have a bit of direction and growth and purpose in your life, which does bring a lot to your mentality. I can vouch for that. Does anybody have any other positive lifestyle choices they can think of that I haven't added here?
Breathing techniques.
I'll put that in meditation.
Yeah, I don't know.
No, nice, no worries. Negative. I guess a lot of the negatives can be, say, opposite or not doing the positives. But likewise, there's drug use, smoking, drinking, sugar's a big drug, pharmaceuticals and illicit illegal drugs. These all have negative consequences on your health. As much as you might think that one is healthy or not healthy, any kind of manipulation of your body's internal chemistry will have a negative effect. There is no free lunch, although it is sometimes good to feed yourself. I'm not saying avoid all sugar, I'm not saying avoid all alcohol, but I'm saying that it does have an effect and a negative effect with that, and so you need to balance it out with the potential positive effects you're getting from it. Polluted environment. If your lifestyle choice is to be in a polluted environment, or to cycle through the city, you're going to get a lot of particulate pollution damage in your body. They say that if you live in some of the polluted cities in the world, say Beijing or Mexico City, it's the equivalent of smoking 5 packs of cigarettes a day. It's pretty horrendous. Another one, stressful environment. If your lifestyle choice is of a high pressure job, this will cause physical and mental consequences on your life. Can anybody else think of any negative lifestyle choices that one could make?
Bad diet.
That would sort of come under the sort of the opposite of this.
Yeah.
No worries. Treatment regimes. Prevention and treating. Preventing is to, stop it from happening in the first place. If there's a physical disease, such as, let's say, obesity, that can be prevented with exercise and healthy diet. Other things like muscular degeneration or diseases such as, tendinitis, these can be improved with stretching and, I guess, anti-inflammatory diets such as having lots of turmeric in your diet, that sort of thing. Healthy diet can prevent disease infections such as food poisoning from E. coli, because you've got a very strong gut that is able to fight off that infection. Vaccination is a way of preventing you from getting a viral disease, because it allows your body to get used to and produce the necessary immune response cells to fight off any viral disease that you get. And pedigree analysis, it can prevent inherited disease, because by using it and then finding out that your child has a 50% chance of getting an inherited disease, you could choose not to have children, and therefore preventing the disease from ever happening. It's a pretty brutal way of doing it, but it's a very effective way of doing it. Can anybody think of any other ways you could treat diseases? Sorry, prevent diseases.
Could you apply this to mental health?
Yes, you could.
So you could say like therapy and stuff like that to like help prevent anything like worsening your mental health.
Exactly. If you've got a strong... Hello?
Oh, I was going to say, washing your hands regularly.
That's a good one.
Yeah.
Fantastic
That's very
one.
key at the moment.
That is. I'm surprised I didn't think of it. Thank you. This is why I need you guys here. Washing hands. So
Sounds
With
like
soap, apparently soap and water is the best for washing hands with, not like the things that you hand sanitize.
antibacterial. Yeah.
Yeah, they're not as good as just using normal soap and water. I was told.
So soapy water is really, really effective because the soaps break down I think it's the phospholipid. So it breaks down the cell walls in the viruses, whereas alcohol does it as well, but not quite as effective as soapy water. What you want to do with it is, when they're saying, "Oh, you should wash your hands for 20 seconds."
Yeah.
What they actually mean is, get your hands wet, put soap on it, rub your hands with soapy water for 20 seconds, then rinse it off.
Oh, I've got a good one.
Yes.
Practicing safe sex.
Yeah. That's a very good one.
Don't have any exercise.
That's a very good one. Cleanliness. Nice. I'll try to remember that. Fantastic. Treatment. Antibiotics. If you've got a bacterial infection, let's try to kill it. Pretty good one. Drugs. There are some drugs that, like antibiotics, disrupt they work similarly to antibiotics. So, has anyone had athlete's foot here? Most likely, at least a few of you have. So you can rub powders and creams that kill the fungal growths on your feet. There are also other drugs that can. I'm trying to think of examples. I'm trying to think of examples. So if you've got brittle bones, you can take drugs that promote calcium absorption into the bones. You can take supplementation. That's probably a good one. Supplementation like vitamin K, which allows your bones to uptake the calcium more regularly. I'm surprised I spelled that right. Nice. Surgery is a good way to treat diseases. If you've got cancer, cut it out. If you've got a degenerative bone disease, replace your knees with metal knees. You know what I'm talking about. A good one. Good one that I've just thought of is this will become a big one in the future. Nice. Can anybody think of any other ways you could treat diseases?
Chemotherapy?
Yeah, I guess that sort of comes under drugs, in the sense that you're blasting your system with drugs that kill any fast-growing cells, which is a kind of barbaric way to kill cancer, but it was the most effective way we had for years and years. And that's why hair falls out, eyelashes fall out, because they're fast-growing cells as well, so they get affected by it.
Oh, can I ask a question, but I don't know if this will sound stupid.
There's very few stupid questions in this world.
Well, your nails grow fast?
Yes.
Are they a different kind of cell then? Because if it attacks like fast-growing cells, what happens with your nails? They stop growing?
They can stop growing or fall out, yeah.
Oh, really?
Yeah, because your nails are made from the same stuff your hair is, or pretty much.
Because I knew like your hair and like the eyelashes, but I never knew what happened with nails. Do they come like a lot softer?
I'm not entirely sure, but I think that they certainly are effective. They could become softer. They could grow. They could stop growing as much. So, and also your nails are much more strongly rooted into your body, whereas the hairs have very delicate follicles. So, I think your nails won't necessarily fall out, but they would be much more easily pulled out.
Oh.
And sometimes they could fall out depending on the individual. Some people don't lose their hair from chemotherapy, but a lot do. Some people probably won't lose their nails, but some might.
Yeah.
Okay. How do pathogens affect us? Bacteria such as Staphylococcus aureus or Escherichia coli, also known as Staph and E. coli as their street names. Staph is like a really bad sort of infection that you get on your skin. E. coli is sort of a food poisoning. They reproduce quickly. They can use up our body's resources. So, for example, they can eat the food that we produce, or some nasty bacteria such as flesh-eating bacteria, they can actually consume the cells of our skin or our flesh just generally. But largely they affect us in the sense that after they've eaten, the stuff that they excrete or they poo out are toxins, and these toxins poison us essentially. If the toxin build-up is too much, it can essentially shut down organs. It can heavily reduce bodily functions and can even kill us. It's not fun. It's not fun. Viruses, they're really small. Let's say like 100 to 200 times smaller than a bacteria. Technically, they're not alive. They're a weird one. We won't go into that. You've had that from me for a while now. How they work is that they hijack one of our own cells. They inject their own DNA into the nucleus of the cell. That DNA rewrites the coding of the cell. So now the cell's no longer a normal cell. It's now a hijacked factory, and all of its production is going to be done. All of its function is now to produce viruses, and it will produce so many viruses that the cell gorges and swells up to the point where it just bursts, and then 1 million viruses leak out, and then they infect the surrounding cells, and then they get into your lungs and you cough them up, and they're fascinating, they're genius, but they're terrifying. Examples, and then it kills the cells, and if your cells die, you die. In the way of coronavirus, what happens is that these dead cells burst, and the fluid from the cells leak out into the lungs, and then you start drowning, essentially, because you've got liquid in your lungs.
Nice.
Yeah, it's not fun. Also, your immune system can sort of go into overdrive and say, we need to kill these viruses quick, and go and attack the cells in your lungs to try to get rid of the viruses, but that in turn bursts the cells, which causes the fluid to leak out, and then you drown in your own lung fluid and blood. It's real not good. It's really not fun. So stay safe, guys. Examples of viruses: AIDS, corona, influenza, also known as the flu, SARS, which is a type of coronavirus, but also herpes. You've all had the flu before. You wouldn't have had SARS. Most of us will eventually get herpes. Most of us will probably get the corona eventually, and hopefully none of us will get AIDS. These are the main two that you need to know for the assignment, but just for your own personal interest, I'll talk about other pathogens that can affect us. Fungi, similarly to bacteria, they multiply, use up our resources, and produce toxins. They are resistant to antibiotics though, and so need different type of cell membrane disruption. They can cause rashes, nail infections, an athlete's foot, ringworm, which is not actually a worm, it's just sort of a circular pattern of a fungal infection. Okay, prions, definitely don't need to know this, but again, it'll hopefully interest you. So prions are a special type of protein that disrupts the way that proteins fold, and therefore the shape of the proteins in the brain. If the protein shape is not right, it doesn't function correctly. And if it doesn't function correctly, messages don't get sent properly through the brain, and it stops functioning well. If it stops functioning well, you get neurological diseases. And the symptoms of these diseases can include a very quick onset of dementia. So you can go from normal to full-blown madness in like a few months. It can cause hallucinations, muscle stiffness, or decline in your movement functions. It can cause confusion and fatigue, slurring of speech. It's not fun. The most common way you get prions is by eating the brain of another animal. Now, I'm not saying that you should never eat brain. It's actually a pretty good cut of meat, but it's the one most risky to cause you disease. I'm not entirely sure of, and I apologise in advance if this is not what happens, but I think a prion was responsible for something called mad cow disease, where cattle were fed food that included other cows, and specifically the brain of other cows. And this prion got into them and essentially caused holes in their brain. Not fun. Vaccines. Now, hopefully that you all know the pros and cons of vaccines, but I'll quickly outline the ones that I can think of. Pros: herd immunity. If something like 80% of the population is immune to a disease, then the disease will fizzle out pretty quickly. The disease can no longer, or specifically in this case a virus, can no longer have a sufficient amount of hosts to keep spreading and grow. Vaccines are brilliant at preventing diseases that cannot be cured, or cannot be treated. That should be a better one. Cannot be treated. That's a good one. And they often cause a lifelong resistance to the disease. There are a few risks involved with vaccinations, such as it can make you ill. It can give you the disease it's trying to prevent you from getting, and it can also cause a aggravated immune response, which can cause other problems, but largely these are very rare, and the risks of it are so astronomically outweighed by the benefits that they are, although good to be known, they are negligible. So they are, that's a fantastic word and one of my favourite words. Negligible means close enough to zero that we don't need to think about it. Can anybody think of any other pros for vaccines?
Make your immune system stronger.
Yep.
It prevents. Wait, hold on. I literally just had it up. Give me a second. I'm just looking at my phone.
So it triggers the immune system to produce more antigens, the antibodies to what's it called, to kill the pathogens that are produced by the disease.
Yeah, so that's sort of how the function of the resistance disease works.
It prevents 2 to 3 million people dying a year.
Is that just in the UK or is that globally?
I think globally, I'm not sure. It just said it on Google.
Another pro, sort of inspired from your point there, Steph, is it's proven to be incredibly successful. That's, although it sounds silly, that's a very good pro to have. If someone came up to you and said, "Oh, that disease you've got is a pill, but you've only got a 10% chance of it actually helping you," or someone came along and said, "Here's a pill, 99.9% gonna help you," which one would you take?
The second one.
The second one, if all the rest are the same. Yeah, so it is a pro, definitely.
Some of them aren't actually that expensive as well. Like some are, but like some are quite affordable if you don't get them on the NHS.
Yep. So often cheap. That's a good one.
They're mass produced, so like you have easy access to them.
Yeah, fantastic. Nice, thank you. Cons. Always a touchy subject.
I struggled with cons on my thing.
Pardon?
I struggled with cons on my assignment.
Because unfortunately there isn't really a open debate where we can actually discuss the cons. It's a very much a, if you say anything bad about vaccines,
vaccine good.
Yeah, vaccine good. There's if you even mention any potential negative, or you're a conspiracy theorist, flat earthist, or what you're doing, get out of society, which actually largely is a good way to approach it, but also for the purpose of discussion and freedom of communication and philosophical debate, it's not very healthy. So the cons I can think of, and they're not many, they only work for viruses. They don't really work for bacterial funguses or prions or other diseases. It's a preventative method. It won't help you if you're already infected. It does cause sickness, although this is very rare in the case. And that this is not proven. It's more Andy's logic, so take it with a pinch of salt. It potentially, like antibiotics, could promote viral resistance. So, for example, if everyone's immune to a certain type of flu, then the only flu that's going to spread is going to be one that has a mutation that allows it to get around the vaccine, which means that you almost promote mutation within the viruses in order for it to survive. And then what could happen from that is that one of these mutations could be a bad one. So it's a kind of thing of, maybe it's better to have a mild flu that we can't get rid of and it's just here forever, than eventually maybe having a flu that mutates that actually causes a lot of harm. Although flu does kill people each year, and a lot of people each year, but it's just a thought in my head that could be an argument against it. However, largely vaccines are just way more pros than cons. Way more pros than cons. Can anybody think of any other cons?
Side effects.
Every country has access to it, so like not everyone is vaccinated. So you know, like the poorer countries might charge more, so not everyone has it. You know what I mean?
That's not. I do know what you mean, and that's a very good point. However, it's not quite a con of the vaccine itself. It's more a con of sort of the distribution of it.
Oh, okay.
but it's definitely something you could write about in your assignment. Don't feel like you can't do that. Just for the purposes of this presentation, it's not a strict con of the vaccine itself, so I won't include it. However, it is in this recording, so people are aware of it. So thank you.
Sometimes the vaccine doesn't work because it's not compatible with your immune system.
Yeah, sometimes it doesn't work.
It isn't compatible with your immune system.
What do you mean by not compatible with your immune system?
Sometimes people's immune system can be weak. So, like, I can't really explain it, but like,
Or like your body rejects it.
yeah,
Just
something like
rejects
that, yeah.
Yeah, so that
The
sort
actual
of, it
vaccine
could
itself.
cause sickness, I guess.
Yeah, something like that. Yeah, something like that.
Okay, nice, thank you. Pedigree analysis. Okay,
Hey, I used that picture.
nice. This was the smallest one that I found that seemed to work nicely. Pedigree analysis, to sum it up, is you have a look at your family tree. You have a look at all the people that have been proven or shown symptoms of that disease that runs in the family. You mark them down. You then build up a nice record, a family tree of all the people who potentially have it, or most likely have it, or definitely have it due to it being confirmed. From there, you're able to work out whether the disease is a recessive or a dominant disease in terms of the alleles, and from there you can work out the likelihood of you having it and the likelihood of your children having it. How this is done to prevent disease is that if you know that through your family tree and the fact that none of your parents have symptoms but it's a recessive gene, there is still and then their parents, one of them did have it on both sides, there's a possibility that both parents have recessive genes. That means there's a possibility you have a recessive gene, there's a possibility that you have the disease itself, but also there's a possibility that your children could have that disease. I could have phrased that slightly better, but I think you know what I mean by this. If you don't, let me know and I'll try to re-explain it. If you know the possibility or the chance that of your child having the disease, you can prevent that disease from occurring by not having children. Brutal, but effective. If you know that you've got a 100% chance of not having the disease because it's a dominant disease and you don't have it and your partner doesn't have it and your parents don't have it, but it did run in your grandparents, but you know it's a dominant disease by having a look at a pedigree analysis, then you can be very safely assured and confident that your child will not have it either. For example, haemophiliac. Haemophiliacs are people who can't produce enough platelets in their blood to form blood clots. And so they don't get scabs, essentially. They just keep bleeding and bleeding, which is pretty bad if you don't want to bleed to death. So for a haemophiliac, a nosebleed could be a very dangerous situation. For a haemophiliac, cutting your finger or getting a paper cut could be a dangerous situation. Because fingers are hard enough to stop bleeding in themselves, but if you don't have really a bodily ability to prevent the bleeding, it could get tricky quickly. I'm not really going to run through the explanation of this, but from this you can work out whether somebody's going to be a carrier. So for example, a normal female here who doesn't have it and somebody that does have the disease could produce normal offsprings but also a carrier. So you need both parent's inherited gene to show the symptoms, essentially. So for example here, carrier female won't show any of the symptoms but won't necessarily know. A dominant male could produce dominant female, dominant male, another carrier, that sort of thing. However, the only way they would have known this on this side is to look back in the family tree, further past the great grandparents, to see, is there a what do you call it? Is there a dominant somewhere in the grandparents? Because if this person doesn't know that they're a carrier and assumes that they're not a carrier, then there's no chance of their children having haemophiliac disease, because they'd only be carriers. But because they've got a carrier and it's a dominant and a carrier, the children could have the disease. It's quite tricky to explain, but for the purpose of your assignment, it can be used to prevent disease, because if you know the chances of your children having disease, you can stop having children, and therefore the disease doesn't exist. Bacterial resistance to antibiotics. Antibiotics work via a few methods. The main ones, and each antibiotic functions differently, is breaking down the cell wall of the bacteria, interfering with the reproduction or the cell division, the multiplication, or blocking their protein production, which is the way that they send messages internally. If you blitz a load of bacteria and don't properly kill all of them, then there's a chance that a few might survive, just because they didn't quite get the full brunt of the antibiotics, and they're slightly stronger, so they can resist it just a little bit. Now these will be the only ones who survive, and therefore will now reproduce, multiply, and suddenly the bacteria that's now there is slightly stronger at resisting the antibiotics. So you blitz it again, and normally this would kill all the bacteria, but you don't do it properly, and actually now a few more survive because they're slightly hardier, and these hardier ones are now more resistant to the antibiotics, so then they're the only ones survive, so they're the only ones that multiply. And now you try it again, and suddenly you've got a load of bacteria that's saying, nah, we've seen this a few times, you've killed all the weak of our species, but we're the strong ones that are left. Well, you're not getting us now. So this leads to things like MRSA, which stands for, someone help me out here, medicine resistant Staphylococcus aureus. So essentially imagine a skin infection where it just chews away your skin, but you can't do anything about it, which isn't fun.
Except cutting off your limb that it's in.
Yeah, but normally it's spreading your skin anyway, and it just needs to grow, so it won't necessarily help. It's not a fun one to get. It's one that essentially, yeah, it's not fun. It's not fun. Evaluation, the distinction part. Now, you have to listen carefully on this one, because I won't be able to necessarily write it in words as effectively as I'll be able to communicate it through voice. So the distinction part is, how can pedigree analysis for vaccination and antibiotics be used to prevent and or treat childhood illnesses? Now, with the evaluation, you need to look at the pros and the cons of each. You need to write or discuss the limitations of it and show how they can be used to prevent or to treat. For example, pedigree analysis is very effective at preventing disease, in the sense of, if you know that your child's going to get the disease, you don't have children, and therefore disease doesn't exist. However, if you go and have a children anyway, the pedigree analysis isn't effective. You can't do anything about that now, because analysing it won't actually help if you don't follow the advice of the analysis. Vaccination, fantastic at preventing diseases. I've just explained how the vaccination works earlier, and we've discussed it. However, it doesn't prevent sort of genetic diseases. It doesn't prevent bacterial infections. It does not prevent physical ailments. Antibiotics don't actually prevent diseases. They're used to treat diseases. Well, technically they could prevent a bacterial disease, but I really don't recommend using it as a prevention method. It's actually very ineffective as a prevention method, because by blitzing your body of all your good bacteria as well, just so you have less of a chance of getting a bad bacteria at some point in the future, it's stupid. It's like saying, oh, I'm going to go on chemotherapy now just in case I get cancer in the future. It's not advised.
It doesn't work like that.
It does kind of work like that, but it causes you way more problems than you want. Okay, now in terms of treating, pedigree analysis doesn't treat a disease. Vaccination doesn't treat a disease. Antibiotics do treat a disease, but only bacterial infections. So, in terms of the evaluation, you want to say briefly what pedigree analysis, vaccination, antibiotics are, how they prevent diseases or treat diseases. You want to weigh up the pros and cons of it, and then you want to show how, by using multiple of them, you could prevent a disease or treat a disease. So, roughly what they are, what they do, the pros and cons of them, in a sense, the limitations of it. So, for example, vaccination can't treat bacterial infections. Antibiotics aren't good at prevention. It's sort of a collective written bit showing you've got an understanding on how using multiple of them can help prevent and treat diseases, and the limitations of it. Does anybody have any questions when it comes to that? Does that make sense?
Yeah, that makes sense. Yeah.
Yeah, I
Yeah,
did.
that's
Totally.
Nice. I'm glad. I'm going to have to love you and leave you now, unfortunately, because I've got a meeting in 5 minutes. I'll be uploading this in a bit,